Hi, this video demonstrates how a PID controller can be used to regulate the roll angle of a 3 degrees of freedom helicopter. The system is driven using two DC motors, which act on propellers that are mounted on one side of the arm, while the other side is fitted with a counterweight. If a positive voltage is applied on the back motor, the pitch angle becomes positive. If it is applied on the front motor, the pitch angle becomes negative. The variation of the pitch also acts on both of the other axes, but the study of these movements is outside the scope of this demonstration. Using Lagrangian mechanics, a dynamic model of the plant is derived. This model is then linearized around an operating point, resulting in a transfer function from the back motor voltage to the pitch angle. The gain is a function of the mechanical and the electrical parameters of the system. The PID controller is designed using pole placement. The proportional and derivative constants are computed to stabilize the system and impose a given value for the damping ratio and the natural frequency, which shape the overshoot and the settling time of the step response. The integral constant places the third pole sufficiently fast to neglect its effect on the dynamics, but not too fast to avoid motor saturation due to sudden jumps in the control effort. The controller is then discretized using the bilinear transform. The sampling period is chosen based on the time constant of the filter action introduced on the derivative action. The discretized controller is then uploaded to a DSpace 1104 controller board. This board outputs the counter voltages, which are amplified to a proper level to drive both motors. The feedback is achieved using encoder measurement of the pitch angle. A graphical user interface is then developed under the control desk software to specify the desired set point and monitor the output variation. Applying a 30 degrees step input causes the output to reach the set point in less than 3 seconds, with an overshoot smaller than 5 seconds. I hope that you enjoyed this demonstration, and I thank you for your attention.